Hello everyone and welcome back for DMS lecture. So previously we was discussing about the pump. We have seen the classification of pump, then working, then some mechanical seals, etc. etc. So today we will discuss about the some classification based on the flow direction, then what is the NPSH, then how the cavitations can be occurred, and what is the uh, priming process. Okay, so as we are discussing about the centrifugal pump, uh, with respect to the fluid flow through the pump, there are three types. First one is a radial flow, second one is a axial flow, and third one is a mixed flow. Now, in a radial flow pump, in the radial flow pump, the liquids enter at the center of the impeller and it's directed out along the impeller blades in the direction right angle to the pump shaft, which is we have seen in a normal centrifugal pumps. The impeller of the typical radial flow pump and flow through the radial flow pump are it's shown in figure. So that is nothing but a simple radial pump which we have already used in our day-to-day practices. Axial flow pump. In the axial flow pump, the impeller pushes the liquid in the direction of parallel to the shaft. Axial flow pumps are sometimes called as a propeller pump because they are operate is essentially the same as the propeller of the boat. The impeller of the typical axial flow pump and the flow through the radial pump is look like this. Okay, so from this direction the water enters and through the blade it rotates, it moves out and it leaves from this direction. So the in axial direction the water enters and leave. The blade design is look like that. So the maximum blades are on this type of pump rotor are 3 to 4. Then mixed type of flow pump. Now here the characters of axial and radial that mixly, or you can say the combination of these two can be uh, these both characteristics are in a mixed type of flow of pump. As a liquid flows through the impeller of a mixed flow pump, the impeller bed pushes the liquid out away from the pump shaft to the pump suction at the angle greater than 90 degree. The impeller of the typical mixed pump, a flow pump, and the flow through a mixed flow pump, which is shown over here. Okay, you can look the blade type or the manufacturing of the blade. It's look like a axial flow pump for a propeller type, and the water in, or you can say the direction of the water is from 90 degree. Okay, so it can move the water the straightly the water comes in. Just a minute. Here we can easily look. So from this direction the water comes, and because of this such angle which is greater than 90 degree, so here it moves from in this way, so both axial as well as radial uh, water what you can say blades are made in a such manner that they can possess the design of axial, that is a impeller type of propeller type of impeller, and about the water leaving, that is in a axial direction and leaves in a radial direction. So both manners we can follow over here. Now if we have to suppose give a water at a very high uh, head, at that time we couldn't use a single pump. So for that purpose we need multiple pumps which we have to uh, attach in a series or in a parallel way. Okay, so that is called as a multi-stage of centrifugal pump. Okay, so pump with the impeller that can be developed a different pressure more than 150 psi between the suction and discharge is very difficult, and the design of that pump is very costly. So for more mechanical economical purpose, to develop a high pressure with a single centrifugal pump is very difficult. So we are including the multiple impellers on common shaft, or we are attaching number of pumps together, so that the whatever the pressure required to deliver that water up to the extended head, that can be achieved. So let's see how the water enters from the water enters the pump from the top left, and the passages through each of the four impellers in series going from left to right. The water goes from volute surrounding the discharge of one impeller to the suction of the next impeller. So here the four impellers are the force pump are attached in a single shaft, so that the the development of pressure can be goes increasingly, or it's called it look like a multiple. Okay, so water enters in a single pump, it can develop a pressure, and whatever the exit of water, that is the input of second impeller, or you can say second pump. So here a simple arrangement is shown. So different arrangements A, B, C, D are shown over here. So it's a multi-stage centrifugal pump. Previously, the different pumps are attached with each other. Now here in a single shaft, we can attach number of impellers with the volute casings. Now priming. So priming is a very important process while before starting the centrifugal pump. So why it is necessary? Because a centrifugal pump is said to be primed when the waterways of the pump are full with the liquid. Then the first put into the service, and the waterways are filled with the air. Into suction supply is about the atmospheric pressure, that is the suction head is a positive. Then this air will be trapped in the pump, and from the airlock, the only way to get out right off it by opening a vent valve and release it. If on the other hand the suction is negative or below the atmospheric pressure, then the priming can be accomplished by using a foot valve in the suction line and using some form of vacuum product producing device. The centrifugal pump, here the performance curve is shown. Centrifugal pump uses the conservation of energy principle. It changes velocity into the pressure energy. As the different head increases, in a x-axis it is a discharge, and y-axis it is a head. So as the head increases, the flow rate decreases, and the performance look like in this fashion. Then loss due to friction. A centrifugal flow pump increases the head losses due to the friction. The curve is shown over here. The friction is caused by the fluid changing direction when they're traveling through the pump, and by clearances with the pump. These losses vary with the both head and flow. Losses are varies with respect to the head and with respect to the flow. So both curves I have drawn. The ideal curve, it should be as soon as the discharge increases, the losses should be decreases. But in actual practices, these are going to be decreases up to the certain level. After that, it again get increased. Then actual performance curve. By subtracting the losses from the ideal gives the actual performance curve. The ideal head minus losses is equal to actual head. It is possible to determine the useful power of pump by the formula. Then losses in centrifugal pump is actual, you can see in a practical manner. The centrifugal pump are previously mentioned. Losses vary with the pump flow and developed head. This means that the useful power changes. The more useful curve is obtained by plotting the efficiency versus flow diagram. Okay, so here the efficiency versus flow as shown. So green color it is shown for head, blue color shown for efficiency, and red color curve is shown for power consumption. Okay, now NPSH, named positive suction head. So if you start a pump and submerge in the water like a sketch below, here, the pump will have a specific capacity as a specific delivery head. If you gradually lift the pump, and the pump will at the specific weight have capability reduce in capacity. When this occurs, the height of the pump above the liquid level is called as a net positive suction head, short form NPSH. The pump suction capabilities are measured by NPSH. NPSH is equal to P plus minus H minus HF minus HVP. And net positive suction head available is by NPSHA in short, where H is a suction head that can be positive if the suction is above the pump. The friction head HF varies from the rate of liquid flow, and NPSH is determined by pump working condition. Then NPSHR and NPSHA. Net positive suction head required is noted by NPSHR. For a given rate of flow, pump will have NPSHR, which is determined by manufacturer, and NPSHR varies with the help of liquid. Now you can look the graph where NPSHA and NPSHR both are plotted over here. In actual practices, what should be required, what should be, and in actual working condition, how it behaves, that has shown in a both different color. Now, what is mean by cavitation? Now, if pump have different losses, what kind of losses over there? It could be due to the friction loss, due to the corrosion or erosion of the blade. So what is corrosion? How it can be occurs, and what is the cavitation? So that will be discussed one by one. The cavitation is derived from the word of cavity as the empty space or hollow space. It is caused by the boiling of a liquid at a normal temperature and the low pressure. It is accentuated or heightened by the presence of the dissolved air, which is released when the pressure are get reduced. If the liquid contains much dissolved air, then as the pressure is reduced, the air comes out the solution and forms a cavity or a bubble. Each cavitation bubble grows from the nucleus to a finite size and it carried by a flowing liquid into the region of high pressure, which is the veins of the impeller. Here these bubbles condensed and burst or collapse. The condensation takes place violently, and the character of the water hammering, and also a rise in a temperature. The bubbles follow each other every rapid, and the bursting results in a shock waves which attacks the metal and which causes the cavitation pitting. In the least resistant place, erosion due to the cavitation is the major problem and is accumulated in a high velocity situation. Now the cavitation and NPSH, how they can, what can say, sorry, how they can be collaborate. In a figure, you can see where the NPSHA and NPSHR get um, collaborated, or those curves are meeting at the point A. Okay, it means that there the vapor bubble will not be formed, so the cavitation will not be a problem for that point. If the pump operate to the right of the point A, then the required suction head is greater than the available suction head. It means that the vapor bubbles will occur in a suction pipe. As the vapor bubbles moves through the pump, the pressure will increase and bubble will collapse. This process is called as a cavitation, and it can be caused the several damages to the pump. Now, generally, cavitation is formed under the following circumstances. If the pump has a suck from a great distance, that is, the suction head is too much long. So, in this case, NPSHR is greater than that of NPSHA. So, because of that, during traveling, the bubbles can be generated. If the normal discharge rate has been exceeded, that is the pump speed has been increased by the above rated. So if you increase sudden a pump RPM above the rated level, so at that time the cavitation could be occur. Improper shape of pump entry passage or due to the certain obstruction in the inlet pump, then the when the pump is handling liquid with low vapor pressure such as LPG or LNG, at that time the cavitation may occur. The effect of cavitation: the metal gets eroded and is seen as a small pitting. The rate of erosion may be accelerated if the liquid itself has a corrosive tendency. Audible rattling or a cracking sound may be heard, which can reach a pitch of dangerous vibration. And due to the flow disturbance set up, the entire performance of the machine may be de- deteriorated. For example, the head and the efficiency of pump may be fall below the acceptable value. So this is the outcome of the cavitation. If it is very hazardous because it reduces the life of impeller. Most of the time it attack on impeller and it reduces the life. So it priming is very important to avoid such things. Now regions attacked by the cavitation area. Okay, you have seen over here where it is the cavitation can be occurred. It's nearer to the suction pipe, or you can say where inlet region. Okay, you look at over here also. At the starting stage, the collapse of the bubbles terminals, which the impeller passes. In the fully developed stage, the main part of the vapor bubbles collapse as in the impeller itself, and the rest is carried out by the impeller into the diffuser ring and the volute casing, sometimes even the next stage to the pump. Okay, so that is this much is about the centrifugal pump. So the theory related to centrifugal pump is cover over here. Now from a next lecture, we will discuss the design of centrifugal pump. Okay, so thank you very much for joining this lecture.